Hi guys, welcome to another session of the Starknet Kampala Basecamp. We are diving deeper into the Cairo programming language. And in the last session, we handled some bit of enums. And then as well in this session, we are going to handle something more about enums. And then how to use match control flows in enums. And then we shall as well handle something with managing the projects. How do we package the modules? So, the Starknet Kampala Basecamp, our online sessions happen every Monday, Wednesday and Friday, 8 p.m. East Africa time. And the whole intention of the Starknet Kampala Basecamp is to onboard as many developers to a Starknet ecosystem. Now, what is a match control flow? Cairo has an extremely powerful control flow construct called match. So this allows you to compare a value against a series of patterns and execute code based on which pattern matches. Patterns can be made up of literal values, variable names, wildcards, and many other things. So the power of match comes from the expressiveness of the patterns and the fact that the compiler confirms that all possible cases are handled. So I want us to think of a match expression as I'm basing on the documentation book.cairolang.org. So match expressions help us to expressively handle case scenarios. Yeah. So for example, you have scenarios whereby maybe you are here. They have used the scenario of a coin sorting machine. So coins slide down a track with various side holes along it, and each coin falls through the first hole it encounters that it fits into. In the same way, values go through each pattern in a match, and at the first pattern, the value falls into the associated code block to be used during the execution. So let's follow the example which is being used in the documentation. So we can create a new project. And we can call it, I said you create a new project by saying scab new. And let's give it a name. Let's give it match flow. So we're initiating a new project. So we are giving it match flow. So it's created already. So then let's open that project. Let me first close up some. So I opened the project in Visual Studio Code by saying code, and then in that very directory, I made a mistake. I'm supposed to first change that directory. I've called it match flow. Then I initiate Visual Studio Code. So from there, as you can see, it initiates for me the lib.cairo file. So let me go ahead and create a new file and call it match flow. Matchflow.cairo. So I've called the name of my file matchflow.cairo. And let's now see the match flow in practice. So first, let me initiate an enum, and let me call it coin. I've initiated my enum and I've called it coin. So it can have many holes. So in this case, we are referring the US coin. We are benchmarking the US coin, and here we are. So now we are going to write a function which uses the match flow to handle a particular case for every case scenario in the enum. So it's taking in a parameter, and it's taking in a parameter which is benchmarking the coin. So it's returning it 4252. So for the case where our coin is in the penny, for the case where our coin is a penny, it means the number of cents are 1. And then for the case where our coin is nickel, it means its value in cents is 5. And for the case where our coin dime, it means its value is 10. The case where our coin is its value here is 25 cents. So that's how we are using. That's one of the applications of the match. How we can use match in practice. So first we list the match keyword followed by an expression, which in this case is the value coin. The condition is to evaluate a boolean, but here it cannot be any type. So in this case, our coin is the enum. And then these other ones. So the case scenarios are called match arms. An arm has two parts, a pattern and some code. The first arm here has a pattern, that is the value, coin, penny. And then the equivalent sign here, operator, that separates the pattern and the code to run. So the code in this case is just the value 1. Each arm is separated from the next with a comma. So I don't want to explain that anymore, but we can have another case scenario. So in case my coin is a penny, I can decide to change the expression and print anything. So this is what will happen in case my coin is a penny. It will first print for me. You can write here preferably anything you want. I can say my coin is a penny. And then that's its value in cents. So patterns that bind to values. Another useful feature of match arms is that they can bind to the parts of the values that match the pattern. Yeah? So, I want us as well to note that enums can get out of scope. Enums can get out of scope, and in that they have to be dropped. Yeah? So that's why we have to import to attach the drop trait onto the enum. Yeah? So let's have another case scenario. So let's have as well attach the drop trait to our coin enum. And then we can as well have another enum which represents states in the US. Yeah, and then one of them, or we can have an enum to represent states in Uganda states. And then we can have here Kampala, and then we can have here Wakiso, and we can have here Lira, and then because it can get out of scope, we are going to attach the drop trait. So we are here calling the debug trait because we want to inspect the states. Yeah. So we mostly use the debug trait a lot when we want to inspect the objects. Maybe want to print the objects. Yeah. So that's when we use the debug state a lot. So now let's check out another. So in the previous section, so we touched about a bit in the previous session how to use the option enum. Yeah. So we can as well handle the option enum using match. Yeah. So in this case, that for example, as I said in our previous session, that an option enum has two case scenarios. The first case scenario where it's returning something is returning maybe a validated variable, and then the other case scenario in case it returns an error. Yeah. So the match helps us in the case maybe where it's returning. So we can use the match arms to match the case where in case it's returning something, and then in another case where it's returning an error. Let's follow the documentation and have this in practice. So I can have a function here, and I can call it +1, and it's taking in a parameter which is an option enum. So in the option, it has a U8 data type. Yeah. It's returning an option enum as well, which takes in a U8 data type. So I'm deciding to use a match case scenario here. So we are handling the case where it's returning something. Right here we are matching for the case here. I'm matching the option enum to the case where it returns something. Then we are adding 1 to the value, and then the other, as I said, the option enum has two case scenarios where it returns something, and the other case scenario whether it's none. So the case where it's none, we are taking as well the none case scenario of the option enum. So now here we can have this in our main function. Then we let 5 equal to the option enum, and then we are also letting let 6 so we are referencing it to the to the +1 function, and which is taking in the variable 5, and then let none equal So here what we are trying to do is that we have created a variable, and in each variable, the case scenario where we have posed that let 5, and then we are saying it's 5, we are referring it to the option enum, and as I said, the option enum can have the sum case where it's returning a value to a variable, and then a case where it has none. So in this case, in our variable 5, we are taking the case that where it's positive, it's returning 5, and then we have as well declared, we have defined a variable none, and then we have equated it to the +1 function, and now the +1 function is handling a case scenario where it's none. So that's how we can have match flow in practice. So matches are exhaustive. There is one other aspect of match we need to discuss. So the match has to cover all possibilities. So I remember saying in some previous sessions that in case I think this was in tuples, in case you need to define, you haven't defined some, for example, if I tell my tuple has three parameters, I need to supply 3 arguments in case I need to use the tuple. So in cases where I haven't supplied the 3 arguments, I need to use a placeholder. Now a placeholder escapes, it acknowledges that the 3 parameters are present, but then I don't need to use them. That's what the placeholder does. Yeah. So in this we can as well use the placeholder in a case scenario where I am only interested in one in one match case. Yeah. So in this case, for example, I'm following the example in the documentation. Yeah. So in this case, so having a parameter and then it's referencing the coin. And then returns a bool. So I'm matching, but in this case I'm only interested in one case scenario. And I'm only interested in the dime case scenario. So since dime is the second last, I have to handle the case of the last match arm, of the arm of the match. So by using the placeholder, yeah. So I have to be exhaustive by using the placeholder. So that's how we use the placeholder. So then you can as well use the all symbol. Yeah. If at all you have to, so if at all you want to handle more than one case, which is you can handle that in the match arms by using the all symbol, and the all symbol is this. It's that. Yeah. So let me add a comment right here in my code in case you want to handle more than one case. You can use this symbol. Yeah. So for example, in case I want to handle cases where my coin, it can be a dime and it can as well be a quarter, so I can use that symbol. I'm following the documentation as well. So it's returning a bool. Then I'm matching. So in a case where my coin is a dime, or my coin quarter, all those cases shall be represented by the true. Yeah. And then I'm using a placeholder to acknowledge, to be exhaustive, and then other cases shall represent false. So that's how you use a placeholder. So you can follow the documentation critically in case you want to dive more into it. So let's proceed and let's look at to other control flows. So we are going to look at the whilelet, and we are as well going to look at the iflet. Yeah. So in our previous sessions we looked at loops, and we saw a case study of how we handle using the while loop. Yeah. So in this here we are going to look at how to use the if-let and then the while-let. So while-let and if-let loops, you'll find that we are going to use them a lot in match cases. Yeah, when you are using the match. Yeah, so the if-let syntax lets you combine if and let into a less verbose way to handle values that match one pattern. Someone is asking here that a while-let and if-let also as well loops. Yeah, they are loops. Yeah, so the if-let syntax lets you combine, but when I use a while-let or an if-let, it's like I'm handling two things using one loop. Yeah, as we're going to see. So the if-let syntax lets you combine if and let into a less verbose way to handle values that match one pattern while ignoring the rest. So let's consider a case scenario. So I'm going to create a new file, and let me call it let loops.cairo. Yeah, so let's see how we can use the if, starting with the if-let. Let's see how we can use it. So let me declare my main function. So in case I have a coin, let me just go and copy my coin enum. Let me go ahead and copy my coin enum. Ctrl C, Ctrl V. So I have my coin right there, and then I'm finding here a variable called coin. If at all it's only handling the case in the match where the coin is a quarter. Yeah, and as well I'm declaring another variable count, and then I'm initiating it with a 0. Yeah, so then let me use the match arms right here. Yeah, so if match helps to reduce the number of, it kind of tries to optimize the lines of code I'm supposed to use in the loop. So just imagine, yeah, so for every match case, you have to distinctively explain, you have to distinctively handle every case scenario. But if I'm using an if-let, I can handle only one case in the match. Yeah, so it acts as like a proper substitute. So for example here, in case I want to handle, so if let coin, yeah, so we are letting, if I tell the arm of a coin is a quarter, yeah, and then we are taking a case now whether if it's equivalent to the if it's equivalent to the variable you've just created. So if at all it's equivalent, yeah, we can just print something right here, and we can say, yeah, it's a quarter. And then if it's not, we can just increment our count. Count plus equals to 1. So let's try to run this code. I've made an error right there. Let's try to run our code. Okay, I want us to note how I've attached the drop rate to the coin, because my coin can get out of scope. So, and I have to notify, I have to let the compiler know that if my coin enum gets out of scope, that's why I have to attach the drop rate to it. Please don't forget, always attach that. So let me run my code right here. But first I have to go to the lib.cairo. And then yes, I've added it. So now my code can run properly. So let me run my code. And I remember I said we run by sense cab Cairo run. So my code is running. My code is compiling. In a few seconds it will be done. Yeah, so we return that it's a quarter. Yeah, and that's what we expected. Yeah, so just to go back to our code. Yeah, first we defined a variable coin, and then we give it a case in the enum as equal to a quarter, and then we as well defined a variable count. Initiated it to 0. Yeah, we initiated it to 0, and then we are using the if let case to handle that. If at all, if let coin quarter, yeah, is equal to the coin variable, print it's a quarter, and of course it has to give us that. Yeah, so let's proceed and look at the while let. So the while let syntax is similar to the if let syntax, but it allows you to loop over a collection of values and execute a block of code for each value that matches a specified pattern. So in the case below, yeah, so the while let is a bit similar, yeah, but it enables us to loop over a collection of, for example, if in case I have an array, I have a fixed array, and I'm trying to loop over this array, and I'm only interested in one element in the array, I can use the while let case, yeah, because it's just handling a specific pattern in the loop. So let's have an example where we are using an array. So let me have my, so let me say while let, or let me just use the file I've been using for if let. I can say here. So let me comment out this. I tied up my work. So let me declare my array. Let me declare my array, saying let, and then I'm declaring it as a mutable array. So let mutable array r I'm using the array macro. Let me have elements 1, 10, 20, 30. And then as well, let me have another mutable variable sum. Initiate it to 0. Then let me hand a case. So now I'm going to handle a case, for example, if at all, yeah, let me handle a case while let option. I'm going to use the, as I said, the option enum has two case scenarios where it's handling the value, where it's returning the value, and then where it's returning none. So let me have a case where, and the case where it's handling the value is called the sum. That's the sum case. Yeah? So for every value that is going to be removed from array, I'm going to add 2 to the sum. I'm going to add, 2. I'm going to add, initially I have my sum as 0. So from every value which is being removed by using the pop front method from the array, I'm going to add it to the sum, which initially was 0. Then after that I'll print out the sum. So that's what I want to do. So that's why I have to use the pop front method. And after that, I want to print out my sum is so our code is supposed to give us the sum. Yeah, we're not interested in the array rate here. Our code is supposed to give us, for every element in the array which is being removed, I want to add that element, that number, in this case the numbers, I want to add it to the sum, yeah, by saying sum plus equal value. So, and then after that, when everything has run, I want to return the sum. So say you run our code by saying Cairo run. That's how we run our code. Feel free to ask any question in case you need any clarification on anything. Yeah? In case you feel maybe I'm moving so fast, you can ask any question. So let's go ahead. So here it has given us a sum as 61. So let's go ahead and inspect our code whether it's giving us a correct answer. So initially we have an array which has 1, 10, 20, and 30. So initially it has 4 elements. And then we have initiated our sum to equal to 0. So for every element we are removing from the array, we are adding it to the sum, and then after that we are printing our sum. So initially our sum is 0. So when we remove, and remember, when we are removing, we use the pop front method, and the pop front method removes from the beginning of the array. Yeah? So we start with 1. We add 1 to 0, so it becomes, our sum now becomes 1. Then when we remove 10, remember the pop front method, it removes from the array and then it returns what you have removed. And what has been removed is what is being added to the sum. So, started by adding 1 to 0, and it becomes now 1. And then we add 10 to 1, becomes 11. And then we add 20 to 11, it becomes 31. And then we remove 30 from the array and then add it to the sum, and it becomes 61. That means our answer is correct. Hopefully we have gotten that clearly. So let's proceed. So let's proceed to another concept. We are soon winding up with the Cairo programming language sessions, after which we shall dive into writing Starknet smart contracts, and hopefully we have really understood how to work with Cairo. So let's look at some interesting concepts, and this is how to package our code. So for example, after writing my code, I have to package it. In case you are not a novice in programming, you'll understand that there are what is called modules, what are called packages. Now packages are a group of modules. Packages are a group of modules. So as you write large programs, organizing your code will become increasingly important, as I said, because you're not the only one who's maintaining this code. Just imagine that you have a big team of about 100 people and you haven't organized your code properly. So someone will have a hard time to follow what your code intends to do. Yeah? So we package our code in packages. So Cairo has a number of features that allow you to manage your code organization. These features sometimes collectively referred as the module system. Now a module is just a file. Yeah? It's a file. So a scab feature lets you build, test, and share crates. Yeah? A tree of modules creates a tree of modules that corresponds to a single compilation unit. It has a root directory, and then a root module defined. So the root module, every time we are initiating a project, we are initiating a package, and the root module is the lib.cairo. Yeah. So then modules and views, these let you control the organizational scope of items. Then pass a way of naming an item such as a struct. So let's look at how we can package our code. So once again, I'm following the book.cairolang.org book. Yeah. So a crate is a subset of a package that is used in the actual Cairo compilation. So this includes entry points of the package, and a subset of the package metadata that identifies crate level settings of the Cairo compiler. For example, the edition field, so the metadata, we add it in the scab.toml file, and every package is supposed to have the scab.toml file. Crates can contain modules, and the modules may be defined in other files that get compiled with the crate. So what is a crate root? So the crate root is the lib.cairo source file that the Cairo compiler starts from and makes up the root module for your package. So what is a package? A Cairo package is a directory, and it must contain the scab.toml manifest file, and then in that file it must have a package section, yeah. So then it must have associated source code. So this definition implies that a package might contain other packages with a corresponding scab.toml file. So how do we create a package? So we've been creating packages by using scab new and then the name of the package. That's how we create a package. So this will generate for us a structure. So on first initiating your package, I don't want us to go into because we have been seeing it a lot. You'll have the scab.toml file, then you'll have the lib.cairo file, and then you're clearly defining it that src is the main directory where all the Cairo source files, as you can see. src, this is the main directory where all our source files have to be. And the scab.toml file is the package manifest file which contains metadata. Yeah. So when execution starts, it first goes to the scab.toml file. So in case you need more clarification, you can check out a documentation in regards to that. So now let's look at another interesting thing here, and that's, let's see how we can organize our modules. Yeah. So we are providing a quick reference on how modules pass and use keyword work in the compiler, and how we are to organize our modules. Yeah. So every time you are compiling a crate, the compiler first looks in the crate root, which is the lib.cairo file, for the code to compile. And then when declaring modules, so in the crate root file, you can declare new modules. So for example, we've been seeing by declaring, in case maybe I have written a module, which is a file, so in case I need the compiler to run it, I have to declare, just like how we have done here. I have to declare that in case I want to run let loops.cairo, I have to declare it in the loop.cairo file, because that's, so I'm declaring the module for it to be run. And then as well, you can declare sub-modules. Yeah, you can declare sub-modules under the module itself. So in case I want code from a specific module to be public, yeah, I have to use the pub keyword. If at all I have a module which is using my code in another module, yeah, I have to attach. For example, in case here I've declared, this is my let loops. This is my let loops file. Yeah. But in case I want to use file from the matchflow.cairo file, yeah, I have to come here and say pub I have to declare pub mod. Let me use the perfect example as the root file. Yeah. In case there is something I want to do from the root file, I have to come here and declare pub mod let loops, and then after there I can come and use I use the use keyword. Yeah. So, for example, in case I want to use a specific maybe struct and it's under let loops, I will just come and say, then after as well here I have to declare that this is as well public, it can be used. So I'll just come here and say use let loops. Yeah, and then I have to come here in let loops. I am interested in the enum. Then I have to come here and say coin. Yeah, so you can see it in action. Even the enum, I have to make it public. Yeah, so when you make something public, that means one module, another external module can use it. So that's something to do with. Then as well we are going to look at grouping related codes. Yeah. So there is a very clear case scenario there. Yeah, so you can decide to have a module tree. Yeah, so you can follow the documentation in detail where it clearly defines how to group your modules. But what I want us to note here is the important thing here to note is that declaring, in case my module is external, I have to declare it external for it to be used by another module by using the pub keyword. And then in case as well there is maybe a data structure, for example an enum, maybe a struct, but I don't want to use in a specific in an external module. So the data structure must have been, when I'm constructing it, I must have attached the pub keyword to it. Yeah, so that's how I can call it directly. So you can follow the documentation, it explains everything. Yeah. So now, in case I have many modules, and every time I have to refer to the parent module, so we can decide to use the super keyword. Yeah. In case I want to use the super keyword, it means I'm talking to the parent module, and I can decide to import everything in the parent module by using super followed by an asterisk sign. If at all you're from a Rust background, you can clearly understand that. So let me give us a sample case scenario how to use super. So super means you're trying to refer to the parent directory, and the parent directory in this case contains the modules, maybe the modules you're interested in. So for example here, they are saying use core array trait as array. So core is the parent directory, and then array is a module, and then array trait is an array in the array module. So that's what I wanted to clarify. And they have clearly explained it here, that use module item 1, item 2, and item 3. And then there is as well a clear example here. So, there is a clear example as well here. I'm having structs, I'm having public structs, square, circle, and triangle. And all these are in the shapes module. So if in case I want to import all these structs, I just use the use keyword shapes and then add the structs in the curly brackets. And then you can see how it is there. So then you can as well use external packages in Cairo with scab, but you have to add them in the scab.toml file. Yeah. So that's what is all about packaging. One last thing is separating modules into different files. So this is basically about packaging. So I don't need to attach a private keyword to a module name, because by default a module is private. So I don't need to attach the private keyword. So you can follow the documentation and find more about packaging your code, because packaging code is really essential when you are writing software, because as I said, you're not the only person who is going to maintain the code. Probably you can have more than 1,000 contributors to your code. So that's how, so in case you don't package it properly, someone will get issues understanding your code. So thank you so much. We are going to stop here for today, and we are in our next session. We are going to summarize Cairo, and we are going to start with traits, and then we are going to summarize Cairo, after which we are going to look at Starknet. We are going to start writing Starknet smart contracts. We've been so extensive in Cairo, because Cairo is understanding the Cairo programming language is crucial for us to write when writing Starknet smart contracts. Thank you so much for joining us in this session, and let's keep it strange.